A textile's pH value offers a direct window into its manufacturing history. Testing this value allows us to evaluate how a fabric was processed and accurately predict its future chemical stability. To accurately read that history, we have to pull those chemicals out of the fibers and into a liquid. ISO 3071-2020 is the definitive, globally recognized standard for executing this extraction and measuring the resulting pH. Before testing begins, you need a precise chemical baseline. This requires grade 3 deionized or distilled water with a pH resting strictly between 5.0 and 7.5. You will use this to prepare a 0.1 mole per liter potassium chloride solution. You'll also need specific hardware, a temperature-compensating pH meter, chemically resistant glassware reserved only for this process, and a mechanical shaker. Using exact specifications for your water and equipment ensures your baseline is completely neutral. Controlling these materials up front prevents contamination that would otherwise skew your data before the test even begins. Step 1 is physical preparation. Cut your laboratory sample into pieces about 5 millimeters on each side. This specific size allows the liquid to rapidly wet out the material. During this process, never touch the material with your bare hands. You must use gloves and forceps to prevent human pH transfer from altering the sample. From your prepared bulk sample, extract exactly 2 separate test specimens. Weigh them to exactly 2.00 plus or minus 0.05 grams each. Take one of those 2-gram specimens and place it into a stoppered flask. Add exactly 100 milliliters of your 0.1 mole per liter potassium chloride solution. Give the flask a brief manual shake to make sure the textile is thoroughly wetted out by the solution. Next, transfer the flask to a mechanical shaker. Set it for a rotational or to and fro movement, and let it run for exactly 2 hours, plus or minus 5 minutes. This strict 2-hour mechanical agitation guarantees that any residual chemicals locked inside the textile fibers are completely and uniformly transferred into your extracting solution. Now that the extraction is complete, record the temperature of your solution. Calibrate your pH meter using standard buffer solutions at that exact temperature. Before measuring the samples, condition your equipment. Immerse the glass electrode into your base potassium chloride solution until the reading stabilizes. This diagram outlines the strict 3-beaker measurement sequence. Start by decanting a portion of your first specimen's extract into the first beaker. Immediately submerge the electrode to a depth of at least 10 millimeters. Stir the solution gently with a rod until the pH value stabilizes. Then, ignore the number. Do not record this reading. Decant the rest of that first extract into beaker 2. Transfer the electrode directly into this new beaker without washing it. Allow the solution to stand without stirring until it stabilizes. Record this number as your first measurement. Now, take the extract from your second specimen and pour it into beaker 3. Again, move the unwashed electrode directly into the liquid. Do not stir. Wait for stabilization and record this as your second measurement. Skipping the wash step and leaving the solution undisturbed prevents atmospheric contamination and electrode shock. It isolates the liquid and locks in the true pH equilibrium of your sample. With both measurements logged, you must validate the data before finalizing your results. This formula checks your tolerance limit. Calculate the difference between your first and second measurements. That difference must not exceed 0.2 pH units. If the gap between your readings is larger than 0.2, the data is void. You must discard the results and repeat the entire procedure using fresh test specimens. If the measurements fall within the acceptable limit, average the 2 values together. Round that calculated mean to the nearest 0.1 pH unit. Compile your final laboratory report, starting with 2 mandatory pieces of information: an explicit reference to ISO 3071-2020 and your final calculated mean pH value. Your report must also document the environmental variables of the test. Include the baseline pH and temperature of the potassium chloride solution you used, along with the date the test was performed. Adhering to this rigorous calculation and reporting structure provides a reliable, universally reproducible record of the textile's chemical profile, ensuring the data stands up to scrutiny across the global supply chain.